All right, folks, we're going to do another example here of graphing rational functions, but this time we're going to have slant asymptotes in there. And this is example number 61 for those of you who are playing along at home or who are doing the homeworks along with us. So we're going to follow the exact same procedure we followed for rational functions that did not have slant asymptotes. But when it comes time to do the what would have been the horizontal asymptote, we're actually going to end up with an asymptote that is a line, a slanted line, and that's where the term slant asymptote comes from. All right, so let's get right down to it here, and let's start off by doing the same thing we do with every single rational function that we're trying to graph by hand, and that is factor out the numerator, factor the denominator. In this case, the denominator is already a linear factor, so we don't really have to do much to this one except in the numerator. So this is going to tell us that r of x is equal to x plus 4 and x plus 1. And all of this is divided by x minus 3 here. So that right there is the fully factored form. So once we're in factored form, we can go ahead and set the numerator equal to 0. To try to figure out what these zeros are going to be. So zeros are going to be given by x plus 4 equals 0 and x plus 1 equals 0, giving us zeros at x equals negative 4 and x equals negative 1. So we have two zeros for this function here, and now we can start working on our vertical asymptotes. The vertical asymptotes, I can figure those out by just setting the denominator equal to 0. So let's talk about some vertical asymptotes. And we're just going to set x minus 3 equal to 0, which is going to give us x equals 3. So we know we have a vertical asymptote at x equals 3. Now, this is where it gets a little bit more interesting in that in order to figure out what the slant asymptote is going to be, we actually have to use either synthetic division, which is allowable for this problem because we have a linear factor in our denominator, or we can use long division of polynomials. Either of those will work. And I'm not going to actually go through the long division or the synthetic division here. But if you don't end up with the same result when you go through your long division or synthetic division, you may want to go research a little bit more and figure out how to do that synthetic or long division before you can move on with these problems. All right, so let's go ahead and figure out what the quotient here would be. So if I take this polynomial and I divide it on out, I'm going to end up with, so let me write a little note here. This is going to be to figure out our slant asymptote. And a quick note here, we can tell that we're going to have a slant asymptote because the degree of our numerator is greater than the degree of the denominator. I have a second degree function in the numerator and a linear function or a degree 1 function in my denominator here. So if I go through and I do all of that synthetic division or the long division, I end up with a situation or a function that looks like this. R of x is equal to, and it's going to be a little bit long and kind of complicated, but just bear with me here. And we're going to end up with r of x is equal to x plus 8 plus 28 over x minus 3. And there's a couple of different pieces to this here. We have a quotient and we have a remainder. And we want to take care here not to mix these two up and to use only the portion that really matters to us. So if we look, this portion right here, that's the quotient part. And that's really the only part we're concerned with. We're not going to really bother too much with what is the remainder over here. So this is the remainder. And this we can disregard. This is the actual equation of our slant asymptote. So our slant asymptote is at y equals x plus 8. That right there is the equation, EQN, of my slant asymptote. Right there. All right, so I have zeros, I have vertical asymptote, I have slant asymptote. The last thing left to do is to figure out what my y-intercept is going to be. And if I look at my original function, I evaluate r of 0. Well, it's going to be 0, 0, 4 in the numerator, 0, negative 3 in the denominator. So r of 0, so my y-intercept is going to be given by r of 0, which is just equal to 4 over negative 3. So I have a y-intercept at 0, comma, negative 4/3, right there. So now that I have my zeros, my vertical asymptote, my slant asymptote, and my y-intercept, I can go ahead and make my number line, or my information wave rather. So same thing we always do when we're making an information wave. I'm going to start off by just making a quick little number line right here at the top. There's that. I'm going to put a little 0 mark right in the middle so I can tell where the center of that line is. And if I go back to my notes here, I know that I have a 0 at negative 4 and negative 1. So here I have a 0 at negative 1, and I have another one at negative 4. And I'm going to have a vertical asymptote at x equals 3, which is going to be somewhere around over here at x equals 3. I want to reevaluate my function here just to make sure I don't have any multiplicity I may have missed. So each of these linear factors only shows up once in my equation, so I don't have any multiplicity I need to concern myself with. So here we go. I'm going to start off on the top right-hand side because I have a positive degree in the numerator and a positive degree in the denominator. I'm sorry, a positive leading coefficient in the numerator and a positive leading coefficient in the denominator, which means that I start on the top right-hand side. I cross through that point of interest, and then end on a down note right there. And I can go ahead and just label what this means again. And every time that I'm below the x-axis or below this number line, it's a negative. And every time that I'm above, well, that means I have a positive value on my graph. Negative, 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 positive, 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 just like that. So I have my zeros, I have my vertical asymptote. Now it's time for me to start my graphing. So I'm going to lay this right underneath it just to line up nicely. And I have one coordinate, axis, and there's the other coordinate axis. Now, I'm going to go ahead and put my zeros and vertical asymptotes right on this graph. So I'm going to start off with my vertical asymptotes, line it up right at 3. Let's make a vertical asymptote there, 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 there. And I'm going to go ahead and label this because it is very important that I do label this. That's at 3. I can lay my zeros down on the left-hand side at 1, or negative 1, and at negative 4. There's that. And now I can work on this slant asymptote. And now this slant asymptote has an equation of x plus 8. That's the equation of my slant asymptote. And I've seen a lot of folks get confused because there are quite a few zeros and y-intercepts and things that we have to keep track of. But this slant asymptote is a function on its own. So I have to graph this function in order to determine what my slant asymptote looks like. Remember, we're going to disregard the remainder altogether. So x plus 8, let's graph that out. And all I'm looking to do is make a rough sketch of what this function looks like. So I'm going to go up to positive 8 because that's the y-intercept of my slant asymptote. So go up to y equals 8. I'm going to put a little dot right at that y equals 8. And that's going to tell me exactly where I need to be here. So I'm going to make a little dot right there, and I'm going to call that point 8. So now that we have that out of the way here, what I'm going to do is I'm going to go ahead and draw in that slant asymptote. Now I know that the slant asymptote crosses my x-axis on the left-hand side of that 0, but that's just something that I know out of experience. When you're doing these, I suggest you check to see where the x-intercept of that particular slant asymptote is going to leave you. All right, so there's that, and here goes my slant asymptote. It's just like a regular horizontal asymptote, except that it is tilted on its side. It still tells us the exact same thing. It tells us what our end behavior is going to look like as we go further and further out. So one little adjustment I'm going to make here is I'm going to draw this line out just a bit further so we can see where we cross the x-axis. There we go. So there's no confusion about who's crossing what where. All right. So now we know that no matter what's happening on our graph, we're always going to end up and start on our slant or horizontal asymptote. So I can just go ahead and lay that on there, right there. So there is one piece of information that I'm missing from my graph that I have not put down yet, and that is the y-intercept. So where is my function going to cross this particular y-axis here? And it's going to cross at -4/3, which is going to put us about right here. Let's call that -4/3. That's my y-intercept. All right, so now I can use my information wave here to dictate what my function is going to look like. And I know that I'm negative until I cross through the 0 at -4. And then I'm positive for a while until I cross through this 0 here. And I'm negative, negative, negative as I cross through my y-intercept, and negative all the way down as I follow on my vertical asymptote at +3. All right, so that takes us on this side here. So now let's take a look at the right-hand side. And if I notice this asymptote at 3, well, if I'm on the right-hand side, I'm always positive, which means that as I drive down this asymptote here, I come up to this vertical asymptote, I have to make a decision. Am I going to go up or am I going to go down? If I go down, I'm going to end up in the negative regime on the right-hand side of this asymptote, which is no good. My information wave says that if I'm on the right-hand side of 3, I better be positive everywhere. So I just turn right back up. And there's my graph there. It's a little bit crooked right around here, but I would just smooth that out with a nice little stroke of my pen to make it look a little bit nicer there. But it doesn't have to be exact. As long as you have every point labeled on here, we're going to be in fantastic shape. Which reminds me, I have not put the equation of my slant asymptote, which is absolutely necessary. So this slant asymptote, I'm just going to label it down here, y equals x plus 8. There we go. And now this problem is done.